Okay, so the radius is whose segments endpoints are on the center and any point on the circle. So it's from the center to a point on the circle. So this is a radius. And then note two circles are congruent if they have equal radii. A chord is a segment whose endpoints are on the circle. Remember, a segment has endpoints. Okay, it doesn't go on forever like a line. A segment is just two endpoint. It has an endpoint, two endpoints. So it doesn't go on forever. So that's what makes this a chord. Its endpoints are on the circle, so this is the chord here. Any questions over that? Okay, a diameter is a chord that contains the center of the circle. The diameter is the longest chord in the circle. The length of the diameter is twice the length of the radius. It basically is two radii together. This then is the diameter because it goes through the center and touches the endpoints. Okay, a secant is a line that intersects a circle in 2 points. Let's remember a line goes on forever. So we'll have the arrows at the end. So this is my wonderful secant. Any questions over that? Okay, a tangent is a line in the plane of a circle that intersects the circle in exactly 1 point. It can only hit the circle in one spot. So that would be this right here is my tangent. Someone want to turn that off for me? Okay, coplanar circles. Two circles can intersect in 2 points, 1 point, or no points. Okay, so let's draw circles that intersect in 2 points. Kind of like our Venn diagram. Oopsie. Like that. They intersect here and here. Okay, you can also have circles that intersect in just 1 point. This would be like this. Tangent circles. So they only intersect right here. Then we can have they intersect nowhere, where they could have common center or concentric circles. That means one inside the other. And they share a common center. Any questions over that? Okay, next. Okay, in a plane, a line is tangent to a circle. I can only prove a line is tangent to the circle if the line is perpendicular to the radius of the circle at its endpoints on the circle. Okay, so that's something we need to memorize, so let's highlight that. In a plane, a line is tangent to the circle if and only if it is perpendicular to the radius of the circle. So in order to prove that it is perpendicular, we're going to need to try and use the Pythagorean theorem. So let's do that. To prove that ED is perpendicular to the tangent line EC. Our goal is to prove that those two segments are congruent. Not congruent, sorry, perpendicular. That's how I can prove that EC is tangent to D, circle D. So we're going to say that A squared plus B squared has to equal the hypotenuse squared. In order to do that, I need to find the hypotenuse. I need to know this whole side. That's 45 and this is 11 because all radii in a circle are congruent. So if this is 11, this is a radius, then this has to be 11 as well. So that whole side is 11 plus 45. Which equals 56. Does that make sense? Okay. On some of your homework assignments, they will already have the line drawn in, so they're giving you the whole side, so you don't have to add the radius back in. But if it doesn't have that line segment there, showing that's the whole thing, you have to assume you have to add the radius to that number. Does that make sense? Okay. So in this, we're going to do A squared, which is 11 squared, plus 43 squared equals 56 squared. And we want to see if that's true. So 11 squared is 121. (43 squared is 1,849. And then 56 squared is 3,136. 3,136.
It's 43 squared, not 45, right?
43 squared, did I do 45 squared? Yeah, this is 43 squared. Because the 45 is just part of the hypotenuse, not the whole thing. Okay, so from there we add the 121 plus 1,849. So this gives me 1,970. Does that equal 3,136? Okay, so that means that ED is not perpendicular to EC so EC, line EC or CE is not tangent to circle D. That's what that proves. Any questions over that? We're all good? Okay, on the back. Okay, in the diagram, S is a point of tangency. Okay, that means that these are perpendicular. If it's a point of tangency, then TS is perpendicular to SR. That's what that means. That makes a right triangle then. So we have to find the radius, R. Okay, so we're going to use the Pythagorean theorem to find R. Let's review this whole side is R plus 36. Which is just what we had here. That whole side was the radius plus the 45. So that's what we're doing here as well. The radius plus 36. Any questions? Okay, so we should have R squared plus 48 squared should equal R plus 36, the whole thing squared. R squared is just R squared. Uh, 48 squared is 2,304. And then in order to find the R plus 36, what that is squared, you have to draw your box and do the multiplication. Find all the areas and add it all up. So we would do R times R to get R squared. And then 36 times R is 36R. R times 36 is 36R. And 36 times 36 was 1,296. Okay, so we have R squared plus 2,304 should equal R squared plus, we need to combine those like terms, 36 and 36. That gives me 72R. And then plus 1,296. Any questions? Okay, we need to get the R by itself, so we're going to move the R squareds to the same side. Okay, we'll finish this up when we come back from lunch. Okay, so we moved the R squared to the same side, which is very helpful at this point because R squared minus R squared is 0. So I just get left with 2. It's not gonna let me draw right now. Two, three, oh, okay. That's interesting. Okay. So that gives me 200. Nope, still not gonna let me write. There we go. Okay, 2,304 equals, these will cancel out as well. So you're just getting left with the 72R plus 1,296, which makes this a very easy problem now because I just have R. I'm going to move my numbers to the same side. So I subtract the 1,296, subtract the 1,296. 14 and 8 and 0 and 2, 0. Okay, so 1,008 equals 72R. Divide by 72. 14. So I'll get R equals 14. So the radius is 14. Any questions over that? Okay, there is one like this in your homework, so please make sure you do it. There's one like this on your quiz that you'll take on Friday for this, so please make sure you do it. It's not difficult. You just have to remember how to use the box to multiply R plus 36 squared. Okay, our next theorem that we're going to learn is tangent segments from a common external point are congruent. Okay, so that's another theorem we need to highlight. Tangent segments from an external point are congruent. So here we have if CA and BA are tangent to circle P, then CA is congruent to segment BA. Segment CA is congruent to segment BA. Any questions over that? Okay, so here they tell you that AB and BC are tangent to circle D. Okay, and then asks you to solve for X. So that means they are congruent to each other. That means they're equal. So X squared minus 4 is equal to 21. You would add 4 to both sides. You would get X squared equals 25. Okay. Get rid of the squared. How do you get rid of a square, class? Very good. Square root both sides. Where'd it go? It is having a mind of its own right now. Hopefully you guys are following along okay. X squared equals 25. We square root, square root. Class, what is the square root of 25? And -5. In this case, both of them can work because I plug it into my expression here, x squared minus 4. If I plug -5 into that, -5 squared is positive 25 minus 4 would be a positive number. It would only not be able to be -5 is if it made the segment length negative, because the lengths can't be negative. Any questions over that? Okay. Okay. That's the end of the notes for this. Okay, so you guys can start to work on the 9.1 homework. You pick that up on your way in. Okay, we'll do 9.2 in just a few minutes after you guys work on this for a little bit.